My office is located in Pierre within the Department of Public Safety, and I just want to welcome you to the webinar this afternoon. This is the Next-Gen 911 GIS Data and Managed Services webinar, and our content is going to be presented today by the folks from GeoCom. They are our contracted vendor for the GIS portion of our project, our Next-Gen 911 project, and so we're very happy to have them working with us on this project and here to present the information today. This is a repeat of a session that was presented last Thursday. So if you happen to listen in last Thursday, just as an FYI, this will be the same presentation. It's not a two-part series, so you didn't miss anything if you weren't on last Thursday. Just another opportunity to listen in. And I just wanted to take a minute to give you a quick update about where we're at with the state project, and then I'm going to turn it over to the GeoCom folks and let them get to the meat of what you're all here for. So we are well on our way in the Next-Gen project. As far as the GIS piece goes, the main thing we have been doing, at least at the state level, in coordination with GeoCom, has been collecting any existing GIS data from the counties around the state. And so I would guess most of you, if not all of you, played a hand in that and uploaded data to the GeoCom site that they provided. And we are doing very good. Of the 66 counties in the state, I think last time I checked, we were at about 61 counties, I think, that we either had received data on, or we knew if there was or wasn't data existing. And actually, that's been looking really good too. We have so far very few areas with no existing GIS data, so that's great news. But anyways, the remaining, say, 5 or 6 counties that we don't have data for, we have been in touch with them and know that the data is coming, or we're in the process of just kind of finally tracking that down and getting approval from county commissions, usually to release that data. So I think we are doing really great on receiving all that data. And to all of you that assisted with that, and we're so quick to upload your data early on when we first requested, I just really want to say thank you so very much. It's thanks to all of you and the work that you did to get that to us is why I'm able to say we are doing very well on that piece. So, and in all honesty, I thought it was going to be much more difficult to get the data. So I'm just thrilled that we are where we are with that. So that's kind of what's happening on the GIS side. And of course, the folks from GeoCom are going to talk more about what comes next and how that will work. The other piece that's going on right now related to the Next-Gen project is the installation of the statewide phone system, or the CPE, customer premise equipment. And that statewide phone system will have 2 hosts in the state where equipment sits, and the host sites, there's one, they're both in data centers, one in Sioux Falls and one in Rapid City, and then all of the other, all of the PSAPs in the state then will connect to both of those hosts, creating a redundant system. So if one host would go down, the other one would pick up the load, and so we're building in all these backups and redundancies to make it more efficient and fail-proof, so to speak. So both of those hosts were installed in March and have been tested and getting those up and going and running. And since then, they have begun installing the CPE equipment in the Pennington County PSAP. That's the first PSAP that will be cut over to the new phone system, and that is scheduled to happen next month, followed by Brookings, Mitchell, Pierre, Sioux Falls, and Winter, kind of to round out the first group. So we are well on our way, and certainly it will be an exciting time next month when we're ready to cut over that first PSAP. So that's just kind of a quick update as to where we're at. But if you have other questions or concerns about anything I've talked about, you can certainly send me an email or give me a call, or if there's time at the end of the presentation, I'd be happy to try and answer any questions too. I just don't want to take away any more time away from the GIS presentation today. So maybe with that, Christy, I'll turn it over to you to introduce your team and take it away.
Great, thank you. Hi, I'm Christy Hayes. I am the project manager with GeoCom, working with the state South Dakota team on this important project. Also on the phone, we've got Hannah Lord, who's our GIS manager, John Kraft, who is our GIS data manager, and Scott Strom, who is consultant working with, he's with L.R. Kimball, working with the state on their entire next-gen project. So as far as the agenda goes for today, Shawnee had just provided the recap of the next-gen 911 project in South Dakota. We're going to give you a status update on where we're at with the GIS data collection and analysis. We're going to discuss the results code overview, GIS gap analysis deliverables, meaning what's next and what is everybody's responsibilities throughout the project, and answer any questions. We are recording this session, so in case you want somebody to hear the session, we'll have it available for the state to be able to provide. And also, if you have any questions, in the panel to the right of your screen, there's a questions box. Feel free to put your questions in there, and we will answer those throughout the session. Okay, for the GIS data gap analysis status update, where we are at right now, we started this project in late fall, and we requested data from all of the counties, different GIS data, including we received the statewide MSAG and ALI as part of that information too. And we are, as of 4/28, we have 61 out of 66 counties data. So that's great. And we're going to continue to work on those assessments and get those out to each of the counties. When we make those assessments available to the counties, you will have an opportunity to schedule a call with GeoCom to go through that assessment. So just so you know, we are here to help through this whole project. If you have any questions on your data or need assistance in how you should go about maybe remediating your data during this time, please feel free to contact us, and we'll be more than happy to help you through that. We did do a pilot project, and we used Pennington County's data, and this gave the South Dakota project team an opportunity to review what the counties would be seeing in their assessments and make any suggestions, or if we needed to make any changes to how the information was being delivered. We did that through this pilot project. So right now we are moving into getting the assessments out the door to each of the counties, and then we're going to be following up once there's a remediation period is over with, where the counties will have the opportunity to work on their data. We'll be asking for that data again. So we'll get a little bit farther into those details into this presentation, and at this point I'd like to turn it over to John Kraft.
Thanks, Christy. Yeah, I'm John Kraft. I'm a GIS data manager at GeoCom, and I'm just going to kind of walk you through what you can expect to see with the completed analysis that's coming in. I'm going to show you the analysis itself that we did for the pilot project. I'll open up ArcMap, kind of show you some of the examples of inconsistencies or errors that we may have found in the data. I've got a couple other supporting documents that I'm going to show you as well. Kind of everything that you're going to be seeing when we deliver your specific analysis to you for your county. You're going to get a package with a lot of little documents in it. So I'm going to kind of walk you through what you're going to see in each of those. And feel free to, like Christy said, type in any questions as we're proceeding, and I'll try to get those answered for you as well. So with that said, just let's go back and talk about what we've kind of collected from you all. So we reached out and we tried to get a data collection, and some of the data that we were looking at were your road center lines, your address points, maybe some road name aliases, any of the boundaries that you're using within your data. And so what we're doing on all of that is doing an analysis and seeing basically what your status is for this data. There's the NINA guidelines out there that recommend that you hit a 98% accuracy of your data. And so there's a couple ways that we measure that. in terms of these analyses that we do. And I'm going to show you the report in a little bit, and we'll kind of go over that. But this is kind of a high-level overview of some of the data that we requested from you. So what is the analysis? First of all, what we're doing is we're kind of comparing the MSAG and the ALI to your data. We've received a statewide ALI, and we've filtered that based on the PSAPs from the data that was contained within that ALI. The initial gap analysis for each county, you're going to be receiving these reports probably sometime in the month of May. They should start coming in soon. And the results we're reporting are essentially going to be your data compared to the MSAG or the ALI. Once we're all done with everything, there's going to be a final statewide GIS data analysis as well. So looking at how neighboring counties' data lines up with each other. You know, if a center line going from one county to the other, which, you know, they should be split at that county boundary, if they line up. So we'll be looking at topology stuff. We'll be looking to make sure that all of the critical fields within that statewide schema are going to be populated. I'm going to talk a little bit about that statewide schema in a bit too, with the field mapping spreadsheet that you all will be getting with this analysis. Some of the QC checks that we're doing for the analysis are going to be related to the address points. So for example, address point data consistency and completeness. What we're looking there is to see if you're following some standards. So the state's going to be following NENA standards, and some of the NENA standards include using street type suffixes, the USPS street type suffixes, where you have AVE shown as AVE rather than spelled out avenue and stuff like that. We're going to be looking at the completeness of it. Does every address point have a name associated with it or a valid house number? We're also going to look at that address point data, and we're going to be comparing it to the ALI database. So every single ALI record, we're going to go ahead and look to see, does it match an address point? If it doesn't, we're going to report it back as a fallout saying, hey, there's no point in your data that matches this ALI record. Or, you know, there's some discrepancies that we're finding. It matches, but the community is wrong. Or perhaps the naming matches, but the address number itself doesn't exist in your data. It's higher than any of the existing, or it's lower than any of the existing address numbers. So we're going to look at that, and I'll go through the analysis with you in a little bit and show you some of the categories that will break those discrepancies down into. We're also going to look at the road center lines. Same thing that we did with those address points. We're going to look to make sure that the standards that NENA are calling for are being used. We're going to look at the completeness of it, making sure that every roadway has a valid name to it. We're going to be looking to see if all those roadways have ranges assigned to them. The completeness on those roadways also includes the kind of similar check that we were talking about with that ALI. We're going to be comparing that ALI to the roadways as well to make sure that every ALI record could be found on the road, so it'll match the road on a naming. The address number will fall between the low and the high range of a specific side of that center line. So typical checks like that. We'll also look at the roadways in regards to topology. We want to make sure that you can route from point A to point B along these roadways. So we want to make sure that that topology is clean and consistent. Any topology errors that we find will report back as well. And I'll show you some examples of that in a little bit on our map. On the boundary layers that we look at, the main things we're looking for there are that there's no slivers or gaps and overlaps in your boundary data. That boundary data is going to be used in the system to basically identify locations of calls and stuff like that. And we want to make sure that anytime a point is referenced in the map, that it's only going to be intersecting one of those boundaries, that it shouldn't fall in a gap or an overlap. So those are some of the QC checks and stuff that you're going to see in this analysis report. Any questions on any of that so far coming in, Christy? Great. So as Christy mentioned in that agenda outline of this project, we did a pilot for Pennington County, and that was done back in February. And we looked at everything that I just kind of outlined. We looked at the roads, we looked at the boundaries, We looked at the address points. We did alley and MSAG comparisons, and this pilot project was actually quite useful in terms of narrowing out like how we want to report the data to you, trying to make it as easy as possible that when you get these analysis that you can easily navigate to a problem in the map and look at it and identify where these errors are. With that said, if there's an error in the GIS data that originally started as GIS data, that's easy enough to navigate to in a map, right? But we're also reporting MSAG and alley inconsistencies as well, and since those do not start as a GIS layer with geometry, if there's an error on an alley or an MSAG table, basically it's meaning that it can't be found. So therefore, those are going to be more of a tabular search as they can't be found in the map, and so those are a little bit harder to troubleshoot. And I'll show you a couple of those in a moment as well. Some of the deliverables that you'll expect to get with these analysis, you're going to get the analysis itself. It's an Excel spreadsheet. There's multiple worksheets within it. The first one is kind of an overview of your results, and then there's many tabs for the different tests that we do, and I'll walk you through all of those. You're going to get an Esri shapefile as well. One shapefile, it's a point shapefile that you can throw into a map and use to navigate to the specific errors. And then in that shapefile, there's some attribution that will identify and kind of give you a description of what that error is. In the overview, the spreadsheet, it's going to basically include any alley fallouts or MSAG fallouts as well. And then there's comment fields in all of this that we're giving to you. Like I said, it's going to give you a description of the error. The record can't be found, or perhaps the alley address is higher than any existing site structure address. So there's going to be a descriptive information in these, explaining to you what the inconsistency or error in the data is. The whole goal of these analysis is basically for you to use it as a guide map on how to clean up and correct your data. Moving towards the statewide next-gen 911 system, we want to make sure that the data going into that system is clean, it's consistent, and it's accurate. And the authority, or I guess the best local knowledge of each county is going to be you guys. I don't live in your counties, so I can't tell you how to fix it. You're going to have to determine that yourself. So all we're doing is identifying the inconsistencies and errors in the data, and then you'll go and navigate to them and hopefully be able to remediate that data. We're going to do a second set of analysis down the road, which at that point you can then compare your current analysis that we're going to be giving you to that next analysis and see how you have improved over the course of a few months in terms of editing that data. You'll also be able to see where you still need to go, or maybe your numbers got worse for some strange reason. There's all that good information there that you'll be able to find out. As Christy said, with each of these gap analysis that we do, feel free to reach out to myself or Hannah or Christy and say, hey, could you walk me through this analysis? I'm having a little hard time understanding it. I just want a little bit of a human contact on this to kind of go through it and make sure I understand what you're reporting to me. So we're more than happy to do that on any of these. So on this next slide here, I've got a screenshot of the cover page of the analysis, which I'm going to open up in a minute. I also have a bullet here that talks about field mapping spreadsheet. One of the main things with this project is to ensure that your local county data is going to be ingested into the statewide schema correctly. And to do that, we need to make sure that field mapping is done appropriately. So with these analysis, you're also going to be receiving a field mapping spreadsheet where essentially we have outlined the statewide schema that everybody's agreed on. And then there's going to be a field where you would basically type in or write in your field name of your local data and how you want it to map into that statewide schema. So for example, if the state has a field called name for the main name of a road or an address point, but you call it, I don't know, street name, you would basically say map street name into name. So we're going to provide you that field mapping spreadsheet. We're also going to talk about some unique IDs, which are going to be important to be able to trace the data in that statewide schema back to the local authoritative source. So, for example, if you give us a bunch of roadways and we map that in there, we want to be able to track each roadway segment or feature back to that source data. And I'm going to go over a unique ID spreadsheet with you as well, which is part of this package, which you'll be receiving with these analysis. So we'll be going over that. With that said, I'm going to jump into the analysis itself and kind of walk you through what you can expect to see. So this is the analysis from Pennington County. This is the pilot that we did. And this is the overview page. So when you first open it up, you've got this overview tab at the bottom, and it'll basically tell you your county name and give you some information. It'll tell you the data that you sent to us, the date we received it, any notes on it about what we noticed, or if it's got some NENA standard stuff. It'll give you the name of the layer you gave to us. Basically kind of an overview of what you provided. It'll also quantify the results of these analysis here and break it down. So we've mentioned that our target is that NENA target, that 98% threshold. So there's a couple ways you can check your data with that, and so I'm going to talk about that briefly. You'll see down here in these that we have two different sections. One is synchronization checks with street name standardization, and one is without street name standardization. You'll notice on one category we have alley database compared to site structure. We have it again down here. So we're testing it two ways. We're testing it once using a kind of a locator where it'll go ahead and use standards and slightly change values. And we're doing it another way where it has to be a perfect exact one-to-one match. And you can kind of see based on these percentages which one is which. This percentage here is 69.84%, where this one is 83%. So to me, logically, that tells me that this lower percentage one here is going to obviously be related to the one-to-one match. And what do I mean by that? So a one-to-one match is essentially looking at the data and not changing anything. So if I were to compare my alley tabular data to my address points, and I have an address point for 101 Main Street, and street is in my alley is abbreviated ST, and then in my address point, street is spelled out STREET, right? If I say, does 101 Main Street in my alley exist in my points, and there's a spelling discrepancy like that, it's not a perfect match. So it has to be an exact match, and so that's what this one here without street name standardization is looking at. The other one with street name standardization is basically using a locator where it knows that if it's ST and another one is STREET, that they match. And so therefore your results will be a little bit higher on that. It's always a good rule of thumb to try to, when you're going through your data and cleaning it up, to go for that matching category without the standardization. Anytime you use a locator, for those of you that have used it, you're probably aware of this, sometimes you get changes to your data that are bad, that aren't necessarily the best change to make. And so that's not necessarily the best thing in the world. However, if you have a one-to-one match, you know that your data is going to match and it's good to go. So I'm going to kind of show you some tabs on this now to go through it. This first tab here is the GIS Data Review. This quantifies as well the results up here on a more granular level. So we have street centerline spatial review. We'll have a site structure spatial review. We're going to have a street centerline topology review. Are roads broken at intersections and the number of errors, or that the test was not applicable. We're going to have your boundaries, basically a topology check on those boundaries, overlaps and gaps reported back to you. We're going to have a section here on MSAG community polygon topology, once again, if what's reported back to you, and street range review results. Everything in this tab, if there's any errors related to it, are going to be identified down here as I scroll down. You'll notice that there's a results code, which gives you a description of the error. And then there's some attributions here as well. So we have the street name and the range as well that's associated with it. If I pull down this little results code tab, I can see that everything in this spreadsheet is just related to overlapping ranges. As you pull these down, you'll notice sometimes there'll be more, sometimes there'll be less categories. We have an appendix that we're going to hand out as well that basically includes all of these error descriptions and what they mean. And I'll show you that appendix here in a little bit. We quantify the number of results for these overlaps. So let's look at another tab. We have MSAG review. We look at the MSAG to basically see if there's any duplicate results or anything in there. So usually this one will be pretty small, but in this case there's a couple duplicate records found in that MSAG. Alley to MSAG is essentially looking at the alley and comparing it to the MSAG. You know, does this alley record exist in the MSAG? Does it match perfectly? Once again, you can filter these by the types of error codes right here. We also have site to MSAG. So on your site to MSAG, it's essentially comparing your site to your MSAG. And we have all of these codes right here as well. City value not found, or house number not found, street name not found. And we quantify all of those. Alley to site. Site being the address points. Here we're comparing the alley to the site. So address lies between existing house numbers. So 1035 First Street in Rapid City doesn't exist in my address points. It does exist in my alley. And what this is telling me is that that alley record falls between two existing address points. I'll show you an example of that one. And this is the alley to site standard street name right here. So you'll notice alley to site exists here as well as here. This is the one using the standardized locators. You can tell that because my number of errors is lower. This one here, alley to site, the error result is higher. This is that one-to-one match that I was talking about, where it has to be perfect across the board. So you're going to have two tabs for each of these, ones with the standardized results and one with the non-standard. So we have alley to site, alley to street, and so on and so forth. So let's look at some of these errors in ArcMap and just kind of see how we can navigate to them and why they might be errors. Are there any questions yet, Christy?
Not yet. Thank you.
Great. Feel free to shoot questions over if you guys have anything. So here I've got a map of Pennington County, and I've got in this map, I've got my address points data. I've got the shapefile that we're going to create for you. This is the shapefile we're going to deliver to you that contains all of the errors that are in the data or the inconsistencies. I've also got my roads shapefile in here. I've got it twice just to make it fancy labeling and stuff. You don't have to do that in your own map. So I've got some zones, city limits, a county boundary, and some imagery. So let's look at this, this fallout shapefile real quick before we dive into one of these. If I open up the tab down here for the attributes of this fallout shapefile, I'm just going to make this a little bit bigger. I'm going to turn all of these on. We can see that we have an error category. So roads to ESN topology. This is probably a ESN topology error. Segment not broken or snapped at boundaries. So that actually is telling me it's probably related to a street center line. All streets should be broken at boundaries, whether it's a county, a city, or an ESN. It also contains an XY value in here, which you can use or not use. Since it's a shapefile, we can just, you know, if we wanted to navigate to that error, we can double click on this and go straight to it. But the error and the description category are going to be very useful to you in order to determine, you know, what the error is that you're looking at. So all of the data in this shapefile is what's coming out of here, the site to MSAG or the site to street, those types of categories where we can actually put them into a shapefile. Those are what's going to be in this. You'll notice there's only 76 records in this shapefile. It's just a sample for the purpose of this webinar. It's not an inclusive list. These are just some examples that we pulled out. So your shapefile will probably have more than 76 records. Let's go ahead and zoom into some of these. I'm going to turn that layer on. I've got it symbolized, so there's different error categories or different, shapes and stuff. This one here is a topology error, and it's a false positive. I'm going to turn on the imagery real quick and show you something. So in this error, we've got two points. We've got one point here and one here, both of these at this intersection. So this road and this road are not split where they cross. That's the type of topology error we're going to call out for you. In this case, it's a false positive because you wouldn't want to be able to route from an overpass onto a road down below. Those are gonna come up, and the only way to know that that's a false positive is to go and look at it. One thing I would suggest that you do, which will apply to the overall timeline of this schedule, is to kind of bookmark these types of inconsistencies or these false positives so you don't have to look at them again with analysis number 2. In analysis 2, you're going to get those same errors reported back to you. Eventually, when we move into the statewide system, you're going to have an opportunity to flag these false positives or these known issues in your data with a code in a specific field called GC exceptions. And once you've coded these as a specific GC exception, it won't come up again in the future in your analysis reports. That's more towards early next year that'll be implemented. So in the meantime, I would suggest you kind of just bookmark these areas so you know that, oh, that's a false positive. I don't want to go look at that again. If I highlight these points in my layer, we can see that the error is road topology, and a description says unbroken intersection found. So it's very descriptive. It's pretty logical of what the error is here. Another type of error that you might see is a parity error. So if I highlight this guy, this roadway, where, let's see, parity error, where that blue guy is, and I turn on my roads attribute, all the roadways in the database more than likely should have a left and a right range. Your left range is either going to be odd or even, and your right range is going to be the opposite. That's going to be 99% of the time. There are situations where you might have consecutive addressing on, a center line, depending on how the area is addressed. Mobile home parks are notorious for this, where you have consecutive addressing going up one side of the street and back down the other. So there are known exceptions. I mentioned a minute ago that those false positives, this would be a situation where you might use an exception down the road once we get to that point of the project. But right now, if we look at this particular one, we can see on the left side of the street, I have even addressing. I've got both numbers ending in an even number. On the right side of the street, I've got a number ending in an even number. And on the other, the high range of that same side of the street, it ends in an odd number. So there's an inconsistent parity or odd-even value associated with this record. You would navigate to this point. You would identify the inconsistency. In this case, it seems like something that would need to be corrected. You could start an edit session in your map of your local data, edit that attribute, save it, get out, move on. Another example of an error that you might see is a flipped range, where the low range is higher than the high range on a certain side of the street. So here's an example of that. I've navigated to a point that I had previously bookmarked. I can see that my from address on the left side is 22,200. My to address on the left side is 22,098. So this to address on the left is actually lower than the from address on the left. Is that correct? Is it incorrect? That's for you to decide at the county level. Typically, addressing should increase in the direction of the housing. So in directionality of the center line would be increasing as you increase in addressing. And your from address is typically going to be lower than your to address. If we look at the right-hand side of the street, we can see it's actually correct, where it's 22,001 to 22,099. My assumption is there was a typo on, maybe this left-hand side of the street, where an extra 2 got added in there or something. That would be my assumption. So maybe I would go in as my GIS analyst in the county. I would look at that. I'd look at the surrounding streets, the surrounding address points, verify it, and edit it and change it. This is one of those examples where I would say it's more important to focus on these types of range issues, mainly because you don't want to create overlaps in the data. You'll notice if I highlight these points that intersect that line, there's 2 errors associated with this one segment. A lot of times in this analysis, you might have multiple errors associated with one feature, where if you just make one edit, it's going to correct multiple errors. So when you go to a feature to make a correction, we highly recommend that you look at all the errors associated with it, rather than just kind of, I'm going to go through all of this first, and then that second, and then this third, mainly because you might be able to correct multiple errors with one edit. In this case, there's an overlapping range there, as well as a flipped range error. That one edit could possibly fix both of these. So you get 2 birds for one stone. I guess that's the saying. Let's see. Let's look at an overlap example. In this example here, I've got Interstate 90, and I've got an overlap here. So I'm going to go back to my roads. I can see that in my from address, I've got 18,044 to 18,055 or 58. I've got on the other side of the street, I've got the 1845 to 1859. The other side of the interstate, I've got very similar ranging. So if a call were to come in for some reason, bad example maybe on the interstate, because most people won't give an address range, but let's just say they did. Somebody called in with 18,046. The dispatcher that receives that call would have to choose between 2 different locations for that call. So it's always good to fix any of the overlaps in the data. That's certainly one of the more important pieces. If you recall, we looked at that first spreadsheet in the analysis, GIS Data Review. A lot of these issues were overlapping ranges. So that's one of the more important things I would probably focus on first in terms of the analysis report, is fixing those overlapping ranges. Overlapping ranges will also possibly fix other errors as well. For example, like an address point found on multiple streets. That'll happen if there's overlap. So if you fix an overlap and there's an address point that has that error associated with it, I'd probably just fix that as well. Let's look at this one. This is a site structure point not in range. So here we have an address point. I'm going to open up the attribute table for it. We're just going to make that a little bigger so we can see it. This is 22,170 to 22nd Street. So let's look and see what our error says in our shapefile. So it says site to street error, and it's given me a description that says address is higher than compatible ranges. So this is a site to street, so I know that it's an error related to the point in the line. So let's highlight these lines that are surrounding it and see what we've got. So here the street name is 222 Street, so we've got the same street name. Let's look at the ranges. I'm going to order these. So the address number was 22,170. I can see that there's nothing even close to a 22,000 block on these highlighted streets I have. Let's just go ahead and highlight a couple of more of these streets to see if perhaps it exists down the road. I can see the highest range on these streets before it ends is 19,100 block. So in this case, maybe that address point is, it belongs to a farm that's been there for, multiple generations, and it's just, that's the address, and it just falls out of range of typical addressing authority. I would probably want to bookmark that, as I said before, that this is a known error in the data, but it's actually a correct attribution on that point. Or perhaps the address number on that point is incorrect and needs to be updated in my GIS data. A little bit of investigation will need to take place. I would want to, maybe look at the parcel data, maybe look at some plat maps, stuff like that. So, sometimes we'll have to put on a thinking cap to troubleshoot an error and figure out exactly, should I correct it? Should I flag it as a known error? And kind of move on. Once again, you folks are the experts on your own data, and so this particular problem could be, like I said, could be something that's been in the family for generations and they're not willing to change their address. Those are always nightmares. So that's an example of something else you might see. Point not in MSAG. So let's look at this guy. What do we have here? So we have two errors right here associated with 26 Ash Street in Wasta. First of all, we have a site to street error. So same thing as what we saw last time. The address is 26 Ash Street. We can see the ranges on Ash Street are in the 47 to 49, 41. Looks like it starts at 40. So 26 is certainly less than 40 to 44. It doesn't fit within the range of any of those street center lines. So that's why you're getting that particular error of the site to street. It's basically saying the address is lower than the compatible ranges, right? So perhaps same thing as that last example. Maybe this is a bad address number. Maybe it was a typo, and this is supposed to be 46 instead of 26. Maybe it's a historical addressing that's been there forever. The other error that's associated with this point is that address number does not fall within the range of my MSAG. So let's go and look at the MSAG and see, if that's really the case, and maybe what we can do to identify those and fix those. So I'm going to open up the MSAG here real quick, and then we're going to see if we can find that guy. And let's write down that address so we don't forget what it was. 26 Ash Street in Wasta. Okay. Where's my MSAG? Is that it? Yeah, so here's my MSAG. I've got my low range, my high range. It tells me if the record is odd or even. So this is a typical MSAG that I would see. So let's just go ahead and search for Ash Street and see what records we get that come up with Ash Street. So here we have a couple prefixes, a couple of these others, and it was in Wasta. Here's Wasta down there. That's the only one. So the low range is 41. The high range is 45. It's got a parity of both. If I go back to my map, I can remember that the address was 26. Sure enough, 26 does not fall in the range of that MSAG, so that's why that error comes up. So it's a very logical description of why these errors might exist. All right, so now we're going to get to the hard ones, right? So let's look at a couple of things where it's not in the shapefile because it started out as an alley error, right? So I'm going to open up my alley real quick. Actually, I'm just going to open up, well, I'll open up the alley. Why not? If we recall in the analysis that we looked at earlier, if I go to alley to site, I have an address here of 1035 First Street in Rapid City. This address that exists in the alley was not found in my site structure data, right? But since it wasn't found in that site structure data, I can't identify it for you all in a shapefile because it doesn't exist on the map anywhere in the data that was supplied. So this one I actually have to try to find a little bit differently. So if I go to my map and I try to search for that record, what was it again? It was 135 First Street in Rapid City. So I'm going to go to my point and I'm going to search with a query. Most of the GIS users should be familiar with how to select by attribute. I've already typed in my query because I did this to prep for the call, but let's just look for it. So I'm looking for where the street name is 1, street type is street, and the city is Rapid City. If I run that query, it's going to pull up all of the address points that are associated with First Street in Rapid City. I'm going to order these by address number, which is not an integer field, so it orders them slightly weird. But I know that I'm looking for, what was the address number? Let's go back to our alley. I think it was 1035. Yeah, 1035. So let's see if we can figure out where 1035 would be. Here's a 1604. These are the 500 block, 600 block, 700 block, 800 block. So it jumps from the 800 block all the way up to a 1600 block. So what I would do as a GIS user is I might highlight the 800 block, and then the 1600 block. So I know that that alley record of 1035 First Street in Rapid City, that's a valid alley record maybe, or maybe it's an invalid alley record. I don't know. I would have to investigate. But I know it falls, more than likely, falls somewhere between these two yellow points on my map. So maybe there's a missing point in my data. Maybe there's a missing street in my data. This narrows down the geographic region that I have to search in my data to find that inconsistency. So sometimes it's going to be a little bit more work to identify the location of where the error is if it's relating to the alley record not being found or an MSAG not being found. But these are just some suggestions on how you might be able to identify those. So let's look at some of the supporting documents that you're going to get with this analysis. Real quick, just to refresh on the analysis, you're going to have the overview page, which gives you your overall results. You're going to have this first page, which talks about the GIS data review and like range overlap, stuff like that. All these other additional tabs for alley to site or alley to roadways, MSAG comparisons, and stuff like that. One of the things that we're going to give you with this is an appendix, which basically will explain to you a lot of the things that I just went over. It's going to give you the error codes and an explanation of what that error might mean. So this is one of the things that you'll get along with your analysis. The other thing that I said you're going to get is a field mapping spreadsheet. So here is a field mapping spreadsheet that contains the schema for each of the layers that we're going to be mapping into the statewide schema. So this is the statewide schema for road center lines. What you would do is you would fill in the name of the field in your data that should be mapped into the road center lines. So for example, if I have a left from address is the name in my road center lines for the state, and I call it low left, I might type in LLEFT here as the user, and that will be sent back to us at GeoComm, so we know that that's what's going to be used in the long run to map your data into the statewide schema. What we're going to do with this is we're going to create a number of scripts and automated procedures, so whenever you send us and update your data, it'll automatically get loaded into that statewide schema. And it's very dependent on this field mapping spreadsheet. This is going to get to be more important as we get closer to 2016. But I just want you to be aware that it exists. You're going to be getting it, and that's essentially what it's going to do. And it'll go through all of the different feature classes that we're going to be requesting from you that'll get mapped over. Another thing that you're going to be getting is a document on using and maintaining unique IDs. So many of you may already have a method to maintain your own unique IDs. I would suggest that you use something other than the object ID. As you copy and paste data from one location to the other or export or import data, your object IDs often change. What we're after is an ID that's going to remain static for that specific feature, the duration of its life cycle in your data. I don't want it to ever change, and I want to make sure it's consistent and that it's unique. And the purpose of this, once again, is so we can track the data in that statewide schema back to its original source. Let's say something goes wrong with that statewide data or there's an error on it. I want to be able to report that error back to the county with an easy way for you to identify it. So those unique IDs are a great way to do that. This document is just one method of maintaining unique IDs. There's all sorts of different ways to do it. This is using an Esri tool called Attribute Assist, and it kind of walks you through, a little bit of that and has some links to it. I know Don with Pennington County has a script that he uses, which helps him with unique IDs. So that's always a resource that you could email Don on our first webinar for this same series last week. Don mentioned that he had that and he was willing to share it, so that's always a good resource. Let's see, I'm running out of time here, so I think that's everything with the package you're going to get. So you're going to get the shapefile, the appendix draft, you're going to get this PDF, and of course the analysis report. So let's just jump back over to the PowerPoint presentation real quick. The data remediation, once you get this analysis, once again, we're striving for that 98% match rate. Ideally, it would be 98% on that one-to-one match rather than using a locator to standardize. You want to shoot for that level of excellence rather than trying to get it to work with that locator. We realize not everybody has all the time in the world, and it costs a lot of money to fix this data. It's a goal and it's an ongoing target. We have this first analysis you're going to get with your numbers, and then we'll have a second analysis later this fall, so you can kind of compare where you were and where you got to. And maybe you didn't hit 98% by this fall, but you can keep on trying to attain that level. Once you get there, it's just a meaning of maintaining that level. So focus on the discrepancy results identified in the analysis report. That's kind of key. I'd rather than kind of jumping around and looking for known issues or stuff like that, use that analysis report as your roadmap on how to get to the 98%. And once again, if you have questions, by any means, reach out to myself, reach out to Hannah and her team. We're more than happy to help you out with this and kind of guide you through this process. It certainly is a daunting task to correct all of this data. It's very hard work. I'm not going to try to sugarcoat it. As we get more towards that 2016 goal of getting all of this stuff into that statewide schema, I had mentioned bookmarking certain areas with false positives. Eventually, you're going to be able to use this field in the statewide schema, or I'd recommend you create it in your own schema called GC exceptions. You can populate the GC exceptions field with these values here that we see on the results codes overview. This is going to be documentation that's provided to you as well. But essentially, if you get an error on a street, let's say with a parity error, and it's a known error, it's consecutive addressing in a mobile home park, and there's nothing you can do to fix it in your data, you would populate that GC exceptions field with a 104. That way, when we run analysis in the future on your data, we know that you already know that there's a parity error on that, and it's a known error or it's a known discrepancy, but it is what it is. There's nothing you're going to do to fix it, so we won't report it back to you again. Some reminders, the field mapping spreadsheets, we do need those resubmitted to us. Once again, it becomes more and more important the closer we get to that 2016 deadline. I'm not sure if we've assigned a deadline on when we need those back from you right away, but I'm sure when we send you the analysis, we'll have an email attached to that with the directions on that field mapping spreadsheet. The QC fallout focus topology is really important, being able to route from road A to B, so I'd focus on any topology errors. Overlapping road ranges is critical. You don't want any dispatchers that are using your data to have to choose between two different locations in the data. Every second counts when you're dispatching calls. Non-matching street names to the MSAG and alley, if things are not standardized the same, if they're spelled differently, those types of things are great to focus on as well. And with all of that said, I'm going to turn it back over to Christy. She is going to go over some key dates with you folks, and then if we have time for questions, I'd love to answer them, so maybe put on your thinking caps. Thanks.
Thanks, John. Okay, some of the key dates and some of the responsibilities that the counties will have. Like we had mentioned, we are working on the analysis, and we will be getting those out here. They won't all go out to all counties at the same time. They're going to be kind of staggered. So we've got a remediation period for that from May to August. What we've got targeted is getting ready for analysis 2, the second round of analysis. So we're going to be requesting data back again by mid-September for that second analysis. And at that time, that's what we're going to be using for the statewide data set. We also have some training courses that we're going to offer in early November on how to use the system that we're setting up, the statewide system. Included in that will be WebDMS and change request, and lessons on how to use the GIS portal. As far as once the system is up and running, what we'll be needing from the counties is just ongoing updates to the system. and taking any correction action that's needed on the data if there are issues with that. And that's going to be as needed and ongoing for the life of the project. That is all I had on key dates. I don't see any questions yet. Does anybody have any questions?
That's just because I was so thorough, Christy.
Yeah, sure. That is what it is.
Hey, Chris.
Shawnee?
Yeah, I was just going to follow up. You can hear me, right?
Yes.
If I remember right, the session was recorded, and you'll send me a link or something to the recording at some point so I could share it with our statewide GIS group in case anybody missed it, or if there was somebody else in their office that couldn't listen today, then they would have the opportunity to listen later if need be.
Absolutely.
Wonderful.
Hey, Christy, this is Ted. I'm sorry I wasn't on right at the beginning of the call, but I got on about 8 minutes into it. And did somebody already give the little pep talk?
That we are here to help.
We are here to help. The one that I gave at the end of the last call?
If you wanted to go ahead and repeat it, just because this is a lot of information, we did talk about how GeoComm is available as well as the state for assistance
right.
and remediation for sure, yes. Well,
I just wanted to thank everyone for taking the time to get on this. I'm with the 911 board, by the way, Ted Rooflet, sorry. You know, the importance of this, and most, you know, I don't know, I assume we have all different levels of GIS users on the call, but I guess I wanted to iterate that this data has never been looked at this way before. A lot of this data was created a long time ago and, you know, has been updated, but it's never been analyzed like GeoComm is analyzing it. And there's never been a need to analyze it this way until now. And the reason this is important is because this data needs to be at a high level of accuracy to support the 911 system. This is the data that's going to drive these calls to the right 911 center, and it's going to help those 911 centers locate the caller. So it's critical that this gets done. And this is, you know, 911, I would argue, is probably one of the most important services government provides to its citizens. So we know it's daunting. We know there's probably going to be a lot of things to work through, but it's going to pay dividends in the end. And we would ask you to, you know, give this as much priority as you can. And, you know, we've got the summer and fall here and the upcoming months to get it done, but it's probably going to be a daunting task at first, but it's very important. And if you run into anybody, commissioners, city council, people who say, why is this important? Why do we need to do this? Why do you need to spend so much time on this? You know, give them those reasons, and if they need more information, by all means have them contact Shawnee or the state 911 board or a state 911 board representative, and we can certainly reinforce to them why this is a critical project. So thank you for your time. And that's all I've got, Christy.
Thank you, Ted. We do have one question. Where do we find the NENA standards that were mentioned?
You can go to the NENA website for sure. They have all of their published standards on their website. Shawnee, is that something that you guys want to send out, or we could always include a link to it when we send out the analysis if needed?
That would be fine. Maybe that would be the easiest way, just to include a link when the analysis goes out. Otherwise, yeah, the NENA website, is it, I'm trying to remember if it's nena.gov or org. I'm just
nena.org. But
thank you.
There's so many. I think it would be better if GeoComm just included a link.
The link.
Sure. Or send it out now, because you could spend a lot of time wading through those standards to get to what you're looking for. So.
Yeah, that's a good call. We can send it out ahead of time, because you might not receive your analysis for, you know, a couple weeks or something like that. That'll give you a head start on some reading.
If you're really looking for some light reading.
Right.
Thank you. Do we have any other questions? Okay, well, I don't see anything else coming through. Thank you, everyone, for your time. We appreciate it.
Yes, thank you, everybody.
Thanks, guys.
Bye.
Bye-bye.
Bye, everyone.